So we calculated that tan theta, tan theta was equal to mu s, or that's not calculate, yeah, I guess so. And if we hit both sides by arctan, we can see that theta is equal to arctan, or inverse mu. All right, so you can figure out this angle. That wasn't that easy. How was it done? Well, we needed to understand the forces. So a decent diagram, and even though you're maybe looking at my solutions, don't hesitate to be redoing this in a booklet somewhere specifically tailored to your question. We looked at the vectors, the forces, identified N, identified the friction force, identified the weight, broke the weight up into components, and identified that the net force was 0 just before it starts to skid. And if it's going to be 0, it's going to be 0 in this parallel direction, and it's going to be 0 in the perpendicular direction independently. We establish what are our parallel forces, what are our perpendicular forces. The sum of them should be 0. We need to know what the friction force is. We need to know what N is. We needed to solve for N. We need to know what the weights were. These are components of our weight. We need to know what weight is, mg. And we were just very careful with the algebra. We brought the two equations together by eliminating N through substitution, and we needed to know how to bring sine of an angle and cos of an angle together in one term with tangent, and then we solve for alpha. All right, now we know alpha. Let's go on to part B. So now we know what alpha is. So we know what the two coefficients of friction are. We know what the mass is. Notice the mass hasn't played a role yet. The mass, because the weight was canceled out. The question is, at this angle, find the acceleration. Well, we found the angle at which all the forces are just in balance. If the angle goes up, 1/1,000,000th of a degree more, it's going to start skidding. So now it's skidding. The angle is whatever angle we found plus 1/1,000,000th of a degree, so that angle. So at that angle it starts to skid. Away it goes. The friction force is the only thing that changes. Instead of all the relationships stay the same, this diagram stays the same, except this box is now in motion. It's accelerating down the hill, and the friction, instead of static friction, it's kinetic friction. The equations are identical, but what's kind of nice is we know what this angle is. So we know we can calculate all of these more easily. And now we're looking at motion in the parallel direction, or in our along our x-axis. And we can just use equation A and come up with, given the forces parallel, what's the net force? It's no longer 0. We're gonna calculate what it is. So the net force in the parallel direction is, adding up all the forces, is the friction force, except it's no longer static, it's kinetic. Is the kinetic friction force minus the weight is still pulling parallel to the surface. This is equal to mu kinetic N, and weight parallel is equal to sine alpha times the weight. Let's remind ourselves, and we don't know what this is, but if there is a net force, let's just calculate. We need to know what N is. Okay, so N is, it's still not accelerating in this vertical direction, so we are going to use this other equation. This says that N is equal and opposite, so if I put weight perpendicular over here, and leave N there, N is equal and opposite to the perpendicular weight. So I can substitute that in. Perpendicular weight. And that perpendicular weight, this is cos the weight. And if there is a net force, I guess I can bring out weight, factor out weight, and just have. And if there's a net force, all net forces equal MA. It's no longer zero, parallel direction. It's already been said it's starting to accelerate down the hill. If there is a net force, and we're calculating it right here, it's going to cause this mass to accelerate. So we have the net force is equal to MA, and that's equal, actually I'm going to put it right here. MA is equal to this weight. Weight itself is equal to mg. The masses cancel. So this implies the acceleration is equal to g mu k cos alpha minus sine alpha. Okay, how do we put, let's just review how we put that together. Again, we have the same force diagram. The friction force has changed from static friction to kinetic friction. Kinetic friction is a little bit less. The net force in the parallel direction is what's going to cause this acceleration. The net force in the parallel direction is no longer zero. It is accelerating. Now the equation is the same for it, but it's just not equal to zero. We calculate what it is. It's not equal to zero, and if it isn't equal to zero, it's going to cause the mass to accelerate. What is the kinetic friction? Mu n. What's the parallel weight? It's the weight times sine alpha downhill. N is equal and opposite to the perpendicular weight, and the perpendicular weight is the weight cos alpha. Substitute that in. I can factor out these weights, and it's interesting that the weight is mg,